Here are two questions where I want to look at two equations and find its inverse, like we have done this whole year, where we've taken quadratic and square roots and cubic and cube roots and just finding inverses of everything. We take the graph and we put it into the graphing calculator. We find the coordinate points and we flip x and y. So there's two ways. You can flip x and y right here to get the new function and graph it, or you can take the equation, graph it, and reflect it over the line y equals x. I'm going to do both for each question. So here's the first question right here, and I went ahead and put it into my calculator, and I have my coordinate points right here. So I have 3, 1.11, 1.33, 2, 4, and 10 for my x and y variables, or for my x and y values. So what I'm going to do is take those x and y values and flip their locations. And just take them and flippity flop them. All right. So from here, it's going to give me 1.113, 1.334, 25, 46, 10, and 7. And we're going to graph those two graphs right now. So we're going to take this one, 3, 1.11. 1, 2, 3, 1.11, about right there. Then I've got 4 and 1.33. And then I've got 5, 2. 6, 4. And 7, 10. So my graph looks like this. Pulls in like that, close to the asymptote, and then comes up like this. So I'm going to take those same exact points, and I'm going to use a different color. We have 1.11 and 3. Then we have 1.334. We have 2, 5. We have 4, 6. And then we have 10 and 7. So this graph starts over here and works its way down. So if we look at it, we take this graph right here, we tilt it sideways, we see that we are all equidistant from the line y equals x, which tells us this is how we find the inverse graphically. You can take the x and y values and flip their locations, or you can reflect the original graph of the line y equals x, and you have your graph. You can do the same thing with the next question. Right here, this is what the graph looks like. Here's our coordinate points. Here's reflecting of the line y equals x. We do the same thing. We find the coordinate points. We plug it in. 1, 4, 2 to the x minus 7 is a d value. We're going to go ahead and take those coordinate points. Starting at -2, we have -6.94. -1, we're at -6.88. At 0, we're at -6.75. At 1, we're at -6.5. And then at 2, we're at -6. So if we take x and y and we flip their locations, we would have -6.94, -2, -6.88, -1, -6.750, -6.5, 1, and -1, or -6, +2. So that's what these coordinate points will look like. Let's graph the first one. -2, and negative 6.94. Negative 1, negative 6.88. 0, negative 6.75. 1, 6.5. And then we have 2 and negative 6. So we see that this graph is going to approach this negative 7, and it's going to slowly stretch up like that. So when we reflect it, it's going to come over here and kind of look like the start of a heart. So let's go ahead and look at that one. We're going to be at negative 6.94. 2, 3, 4, 5, 6.94, and we are down 2 units. 1, 2. 6.88, negative 1. 6.750. So we're just really close to these lines. 6.5 and 1, and negative 6.2. So the graph kind of looks like this and approaches this line right here and just kind of comes off this way. We know that we've done this right because our graph is mirrored over the line y equals x. That's how you find inverses of graphs, or inverses of these graphs, using two separate methods, flipping x and y or reflecting over the line y equals x. Here's the first answer, and here's the second answer.